Limiting reactant problems are such a large part of this course that I'd like to put another one in the lecture notes and the lecture outlines. We will do probably 50 different versions of limiting reactant problems throughout the course of this semester. This example has sulfur and copper with our grams of sulfur and grams of copper. It asks what is the limiting reactant and how many grams of the excess reactant are left over. It has the balanced chemical reaction, and so this is, again, a very typical type of quiz or exam problem. You'll find some of these on the homework as well. Find the limiting reactant and the amount of product that can be made. Well, start with your grams of sulfur, do stoichiometry, then start with your grams of copper, and then we'll see which one has the smallest amount. 10.0 grams of sulfur, and when it says sulfur, it means S8. Now, for grams of sulfur, I need to look at my periodic table, which I happen to have handy right here. Sulfur, 32.07, 256.56. I have 1 mole of S8. Now, for every 1 mole of S8, there are 8 moles of copper 1 sulfide. And then for the molar mass of copper 1 sulfide, I get 159.17. Multiplying this all out, 10 times 8 times 159.17 divided by 256.56, 49.6 grams of copper 1 sulfate are possible if sulfur is the limiting reactant. Now let's start with the copper. Copper from the periodic table, 63.55 grams per mole. And this time 16 moles of copper are necessary to make 8 moles of copper 1 sulfide. And the last step is the same in my approach. All right. Yes, everything looks good. 15 divided by 63.55 times 8 divided by 16 times 159.17, 18.8. So with the smaller amounts, that means that I can, this amount of copper 1 sulfide can be formed. Let's see. How many grams of copper 2 sulfate can be made or formed? Good, we've got that first. What is the limiting reactant? Copper is the limiting reactant. Yep, we've answered everything so far. We still have how many grams of the excess reactants are left over to do. Let's see. We can use this 15.0 grams in our stoichiometry on the following page. Find the amount of excess reactant that is left over. That's going to say start with 10.0 grams of sulfur. Then do stoichiometry with the copper to find how much of the sulfur is taken away. There's definitely patterns forming here. Of course, we start with the grams. We do a molar mass upside down, so meaning that the grams are on the bottom. Now for every 16 moles copper, we have 1 mole of sulfur. And for sulfur, 1 mole has a mass of 256.56 grams. Plugging this in, and you can see that getting comfortable with your calculator is really important for this. Sometimes I like to multiply all the numbers across the top and then divide by all the numbers on the bottom. Sometimes I take and I go individually, so 15 divide by the 63.55, just a 1, divide by the 16, times 256.56, 3.78. But as long as you remember that your calculator, and this is not a graphing calculator, this is as complicated as of a calculator as I'm comfortable with. As long as you follow the order of operations, you're going to be fine. You can use parentheses, lots of ways to do it. And definitely make sure by the time you take the quizzes and exams that you're comfortable with your calculator. You know how it works, and it can always do the math that you want. 3.78 grams of sulfur reacted away. And our leftover amount. Start with our starting with, do our reacted away. And 6.22 grams S8 left over. With 3 sig figs, always fine. Of course, if you follow the sig figs using these numbers, you would end up with 6.2, also fine. Add in just another bit here so we can do another percent yield. Suppose only 12.1 grams of copper 1 sulfide are recovered. What is the percent yield? Percent yield is always going to be actual amounts, 12.1, over theoretical amount, 18.8. Times 100%. %64.4% copper 1 sulfide yield.